Welcome to the Explainer. Have you ever written a line of Java and just stopped and wondered, how does this actually work? How does a simple text file you write magically turn into an application running right there on your screen? Well, today we are pulling back that curtain. We're going to follow the incredible journey your Java code takes. Let's get right into it.
So, here's the plan for today. We're going to start with the big fundamental problem, the gap between our code and the computer's language. Then we'll unpack Java's really clever solution, piece by piece, all the way from the compiler to the virtual machine that really brings it all to life.
All right, so let's kick things off with the most basic problem in, well, all of programming, really. How does the code that we, as humans, write and understand, how does that become something a computer can actually use? This is the core challenge every single programming language has to solve.
I mean, really think about it for a second. We're writing these instructions that look a whole lot like English. But way down at the hardware level, the processor, it only gets electrical signals. On or off, 1 or 0. So how on earth do we bridge that huge gap?
And here's that gap right in front of us. On the left, you've got our readable Java code. On the right, the binary machine code that a processor actually understands. They look nothing alike. So there has to be something in the middle, some kind of translator between these two worlds.
So how does Java do it? How does it build that bridge? Well, it doesn't just go straight from our code to the machine's code. Nope. Instead, it pulls off this kind of magic trick, a super clever intermediate step that is really the key to all of its power.
And the first character in the story is the Java compiler, which you'll almost always see called javac. Just think of it as the first translator in a chain. Its whole job is to take that .java file you wrote and do the first, really critical stage of translation.
So here's what that process looks like. First, you write your code in a .java file. Simple enough. Then, you run it through that javac compiler. And now, here's the really important part. The compiler does not create the final machine code. Instead, it spits out a totally new file, one that ends in .class. This file is the result of that first translation step.
And inside that new .class file is something called bytecode. This right here is Java's secret sauce. It's like a universal set of instructions, kind of like assembly instructions, but for a machine that doesn't actually exist in the physical world. It isn't for Windows or Mac or Linux specifically. No, it's a universal language that any system can understand as long as it has the right interpreter.
Okay, so that brings us to the next big piece of this puzzle, the JVM. Because, creating this awesome universal bytecode is only half the battle. Something still has to understand it and actually run the program.
And this is where the Java Virtual Machine, or JVM, makes its entrance. You can basically think of it as a program running on your computer, and its only job in life is to understand and execute Java bytecode. It's the engine that really brings your code to life. And this is the big payoff. Because that bytecode is totally universal, any JVM, it doesn't matter if it's on a Windows PC, a Mac, or some Linux server, it can execute the exact same .class file. And this powerful idea is what lets Java make its most famous promise: write once, run anywhere.
Now here's a really important distinction that honestly trips a lot of people up. Your Java application, the bytecode, is totally platform independent. But the JVM itself, oh, that is absolutely platform dependent. You have to download a specific JVM built for Windows, a different one for Mac, and another for Linux. The JVM is the bridge, right? And that bridge has to be anchored specifically to the operating system it's running on.
So you can see how the JVM is that final, critical translator. It grabs the universal bytecode from your .class file, and only at the very last second, right before it runs, it converts it into the specific native machine code that the local computer actually understands.
Okay, so we've met the compiler and we've met the JVM. Let's zoom out a bit now and see how all these pieces are packaged together. This brings us to two more acronyms you're going to hear all the time: JRE and JDK. The relationship between these things is easiest to understand with this diagram. Just think of them as nested boxes. At the very center, the core, you've got the JVM. That's the engine. That JVM is then contained inside something called the JRE, and the whole JRE is contained within the JDK.
And this table just breaks it down perfectly. At the bottom, the JVM, its only job is to run the bytecode. Go up a level, you get the JRE, the Java Runtime Environment. This gives you the JVM plus all the libraries and other files your application needs to actually run. And then at the very top, you have the JDK, the Java Development Kit. This has everything in the JRE plus the extra tools you need to develop applications, like that Java C compiler we were just talking about.
So this all leads to a really simple rule of thumb. Are you just a user who wants to run a Java app, maybe something like Minecraft? All you need is the JRE. But are you a developer who wants to write and compile your own code? Then you need the whole toolbox, the JDK. All right, let's do it. Let's put all these pieces together and trace the entire path, from one line of code all the way to seeing the final output on the screen.
And here it is, the whole journey. Step 1, a developer uses the JDK tools to write a .java file. Step 2, the Java compiler crunches that down into a .class file full of bytecode. Step 3, the JRE provides the perfect little environment for it to run. 4, the JVM inside that JRE executes the bytecode. And finally, step 5, Hello World pops up on your screen. See? Every single piece plays its part.
Okay, think of this slide as your final cheat sheet. If you're studying for an exam or prepping for a technical interview, these are the 4 points you absolutely have to remember. The compiler makes bytecode. The JVM runs that bytecode. The JRE is what you need to run an app, and the JDK is the full kit you need to develop one. Got it?
So, you see, this whole process we've walked through, it wasn't just some clever technical detail. It was truly revolutionary. It's what made Java such a powerhouse for decades. And it leaves us with a final thing to think about. Now that you actually get the mechanics behind it, how did this one simple idea of run anywhere completely change the software world as we know it?